For the nice intro. First, I would like to start by saying that supervised machine learning is very popular and we all love it. And it is used in basically every domain of natural language processing, starting from part of speech tagging to parsing, named entity recognition, sentiment analysis, document classification. However, it's really important to recognize that machine learning is not magic learning. Especially supervised learning requires large amounts of good annotated data. And there are oftentimes in practice hurdles to obtaining such annotated data. Sometimes there are legal or privacy issues such that not all the data that you want to learn from can be actually externally crowdsourced. In other cases, when it can be crowdsourced, oftentimes the domain knowledge is so intricate that the crowd workers do not have it, and it's not really possible to get quality data that way. And finally, if you pony up some money and you hire expert annotators, they usually cannot annotate massive amounts of data because they're quite expensive. So the focus of today's talk is specifically on overcoming the problem of insufficient and oftentimes inconsistent labeled data. In particular, I will focus on a case study of improving a conditional random field, a CRF model, that is trained to tag and label named entities in search queries. And the proposal I will discuss in addressing this data shortage, a shortage of annotated training data, is to develop a grammar that will label some portion of the training data consistently, as if modeling an ideal annotator. And as a consequence of this proposal, we can leverage the grammar to aid in CRF feature engineering, do some post-filtering of the results of the model and fix some obvious errors, as well as produce more data for other relevant applications. So first, I would like to give you some context on what is the task for which the data is being collected. The task is search query tagging. The goal of query tagging is really to understand the relevant entities in search queries. This is really an extension of a named entity recognition problem. So when a member goes on LinkedIn and searches something on LinkedIn, such as John Smith, software engineer, LinkedIn, Mountain View, they have typed a bunch of words. What we want to do is we want to understand them as entities, like first name John, last name Smith. There is a job title for short, software engineer. There is a company like LinkedIn. There is a location like Mountain View. Or if someone just types machine learning, CMU, they didn't just type a bunch of words. They actually typed something that we call a skill, machine learning, and a school, CMU. So as you see, there were some classic named entities like name, location, organization, but we actually extended a little bit more to add title and skill, which are really critical to our ecosystem of LinkedIn, because you could imagine you may be looking for jobs of specific titles or for skills like data science or machine learning. As well as we made some refinements in company and school as an organization being treated as two separate things. Now, why do we actually care about this? Because understanding user intent improves ranking of search query results. For example, if you typed John Smith, you probably want to go see some member page, not just some random words, John and Smith, in different types of text. And if you understand user intent better, you can produce better user experience. So again, a little bit more about the data. It turns out that search queries on LinkedIn are incredibly short. 98% of them are less than 4 words long. The bulk falls between 2 and 3 words, 78%. And about 20% are 1 word, and only 2% are 4 words or longer. Most of the time, they're actually unsurprisingly people names like Larry Page, but often there are also frequent job titles like project manager or software engineer, as well as skills like data science, machine learning, or some mixture of these things like jobs at Microsoft or data science internships or Google software engineer. So this is kind of how the data looks like. And again, I want to emphasize as part of this talk, the most important types of entities we want to tag is titles and skills. And they have very specific definitions to our ecosystem that are incredibly important. A title is really a noun phrase that can be used to fill in a blank of something like, I work as a data scientist, business developer, salesperson. In contrast, a skill is something you can learn, something you can be good at, or also an area of work. For example, I want to learn blank. data science, machine learning, or I work in the area of sales, marketing, data mining, etc. So it seems like a fairly straightforward distinction. However, it turns out that for crowd workers, this is an incredibly complicated thing to sort of grasp, because it requires reading a lot of instructions. And for one reason or another, even though people gave us very high agreement scores on the crowdsourced task, it actually produced complete noise. Specifically, people consistently label something that is a skill as a title. So they see data science, even though it's given as an example as a skill, but they say it's a title. They see human resources, as they say it's a title. Everything is a title. And as a result, our model can't really learn anything, because everything is labeled halfway this way, halfway that way. Sometimes they're right. Interestingly, they never actually say that something is a title, that something is a skill, when in reality it is a title. So they say salesperson is a title. They don't say it's a skill. But unfortunately, it doesn't help us, because the data comes out to be incredibly confused. Basically, the problem is skill is confused with title in the training set half the time. The CRF model mistakes skills for titles, and that produces kind of bad results on that particular type of named entity. So what we're going to do with this is we're going to make the training data consistent, as well as improve some features and do other CRF-y things. But let's get the bulk of it right. And so what we're going to do we're going to start with focusing on where's the bulk of the queries. Well, they're short. So we're going to only look at the 98% of the queries that are less than 4 words long and ignore these other 2%. We will use crowdsourcing to label locations and names and companies and schools, something that people are really good at understanding. So when they see a name, they really do kind of correctly label it as a name. And then for the remaining, we will build a grammar. A particular grammar that will recognize titles. So what is a grammar? It's just a vocabulary and rules governing the combination. So we will build a grammar that would say, this phrase is a legitimate title. This phrase, I don't know. This phrase is a legitimate title. This phrase, I don't know. And so on. And then we will use this grammar to auto-tag titles in unlabeled queries and add these newly labeled queries, hopefully consistently and labeled well, into the training set, thus solving our problem of inconsistent and insufficient training data. So I will start with some observations. Observation 1 is that people usually understand some new phrase that they may not have seen before as a legitimate occupation title. So if you have never seen something like director of guitar division or senior dental ceramist, which I saw for the first time when I was preparing this talk, or chief happiness officer, you may not know exactly what this person does, but you know there's some sort of officer, some sort of ceramist, there's some seniority there, some importance, or I call one of my cats chief laundry inspector. So that's sort of like you don't know exactly what that means, but you kind of get it's a title. And how do you do that? Well, you look for the syntax and the morphology to give you some hint. In particular, what you're looking for is for the head noun like director or ceramist or officer, and that head noun has to designate what we call a core occupation. That has to be a person. This is why dental ceramist is a title and dental ceramics is not a title. So the core occupation like officer, ceramist, director has to be there in order for this to be a title legitimately, according to our definition that we imposed. Observation 2 is a corpus of member profiles, not queries, but member profiles. Hopefully, you all have profiles on LinkedIn, are very useful to harvest. First, core occupations like officer, ceramist, director, manager, owner, as well as seniority words like senior, staff, principal, and a bunch of modifiers like hardware, dental, happiness, guitar, or basically any words you have that appear sort of in between, as well as the grammatical patterns for titles, meaning how are these words exactly combined most of the time. So we're going to set aside our queries completely and go to member profiles, and we're going to look at member profiles now in order to obtain this grammar that then we will later use to tag queries. So it's very simple. We will start with about 100,000 titles from member profiles. These are things like marketing manager, VP of sales, software engineer, senior data specialist, director of development, and we will tokenize them into tokens like manager, owner, project manager, director, specialist, etc. And then we will annotate frequent tokens with very few select type of annotations. Very few tokens, only the top like 200 or 500 tokens we will take. And we will only look for seniority words, which are very stable. They do not change, like senior, staff, and principal. Very rarely does a new seniority marker come into the language. They're almost like prepositions, which we also look at. And of course, we're going to look for the high-frequency occupation words. They're like engineer, manager, owner, specialist, director, salesperson. There is actually not that many of them. And we will look at occupation marking suffixes. These are ist, are, or, and. Of course, there is a lot of false positives there, but we will still harvest some of the most frequent ones that are fairly stable in the language. And then we will look for anything else that comes our way in the top 200 or so tokens that we will call a modifier. So we don't really know what it is, and we don't really care. It's some word. It usually appears before an occupation or after an of, but we will just collect them. And then we will go back to our titles, and we will replace literally the words with the corresponding annotations, such as marketing manager will become modifier. We don't know what that word is, marketing. It's some kind of modifier. And manager, because I know it's an occupation. Or VP of sales will be occupation, preposition, modifier. Or senior data specialist will be seniority, modifier, occupation. Crucially, occupation has to be present as the head of the noun phrase in order for it to be a title. And that is the one thing that we absolutely look for in order to say this is legitimately a title phrase. And essentially, once we have done this, we have these grammatical patterns, these templates or rules or phrase structures, however you want to call them, that cover a lot of new phrases, because seniority, modifier, occupation is the same pattern for senior data specialist and staff software engineer or staff hardware designer, etc. So with that, we basically, just to restate what I have just said in 3 steps, we tokenize frequent titles, we manually annotate frequent tokens with occupation, seniority, preposition, and whatever modifier, and we replace the tokens that we've annotated with their annotations. So software engineer becomes modifier occupation, and senior data scientist becomes seniority modifier occupation. And we're done. We have a grammar. And so now we're going to go back to our queries that look sometimes suspiciously indistinguishable from titles because they are short. And if we see a query that is 2 words long and it has something we know, we will label it according to our grammar. So specifically, we have, let's say, a raw query like arts instructor or director of partnerships or talent acquisition specialist. We will tokenize the query, and then we will apply our grammar. We will first look for the key occupation word. In the first case, it's instructor or director or specialist. And if we found such a word, then we will look for the rest if we know, especially if we know some seniority or some preposition, and we will apply that. And we will say, yeah, I see this occupation instructor. I know what that is. I don't know what this arts is. I don't know what it means. I don't care. It's probably some modifier. Good enough. We're going to label it as a title. If you saw, let's say, director of partnership, it said, OK, I have occupation director. I have a preposition that I know of. And I have some word. I don't care. It's a modifier. And so on. And we will have been able to label a bunch of titles. If we didn't find an occupation word, when we basically don't know what that was, we have no idea. We cannot make any judgment. So I will skip this and go on. After we've applied the title grammar, we effectively have something like this. Staff business analyst is a query. Somebody issued a query like this. It looks suspiciously like a title. We consider it a title because it patterns exactly according to the grammar that we have built as a title. And then we see something like real estate or human resources or data science, and we say, I don't know what that is. There is no occupation word there. I have no idea. So now we want to figure out, maybe we can learn a little bit about the skill phrases using our title grammar. This is a much harder problem to solve, and that is why we started with the title grammar that has very stable patterns. Specifically, 2 observations. So first, titles often, though not always, subsume skills, but not vice versa. So what is data science? It's the middle portion of something like senior data science analyst. And so if you strip senior and you strip analyst, you will get data science that happens to be a skill. Unfortunately, skills have an incredibly varied morphology and syntax, as well as recognizing a skill requires domain knowledge. For example, business development is a skill, Java is a skill, C++ is a skill, Hadoop is a skill, and Spark is a skill. But the latter two, you didn't know if we were here like 10 or so years ago. Maybe Hadoop you already knew, but Spark you certainly didn't. And that domain knowledge suggests that you actually need to have some domain knowledge database. And where would you get it? Well, you can build some dictionary of these skills, hopefully using some inference in order to learn new things like Spark that didn't used to be there. For the lack of a better approach, we will again reuse our title grammar because we can't get humans to label this consistently. And we will do an inference. This is a noisier inference and a harder problem, as I had mentioned, which is why we started with the easier problem. But we will do this. Again, we go back to our titles from member profiles. We set aside the queries, and we're going to say we're going to use the titles from member profiles and the grammar that we have already built in order to make inference on what a skill might be. And a skill is basically a title without the occupation and the seniority. So if we look at titles like manager, sales and marketing, or VP of data science, or senior VP of corporate negotiations, and we remove things that we know are core occupation words and seniority, like manager or VP of or senior VP of, then we will get, hopefully, though not always, something like sales and marketing, data science, corporate negotiations, etc. Now, there are going to be false positives. This is a much harder task because you can get a lot of the time something like senior Google engineer, and Google is not a skill, or director of Los Angeles Arts, and Los Angeles is not a skill. And so you have to do an additional verification, again, to the best of your ability to remove these false positives by verifying against known collections of text that are locations or companies, etc. And then you build a final dictionary of induced skills that you use to label queries if they match exactly or near exactly, like sales and marketing, engineering, logistics, infrastructure, corporate negotiations. So that way, we were able to leverage something we learned to label queries that fully correspond either to titles or skills, because there's a short queries and we do not care about segmentation problems. So if we find something like special education teacher or real estate consultant or supply chain director or IT security specialist or field service engineer or digital marketing specialist, we know it's a title. And if we find something like finite element analysis, corporate social responsibility, fire and safety, social media marketing, natural language processing, real example, talent and recruitment, these are skills. And that will have some false positives that titles generally do not have, because accidentally something like Google or Los Angeles might sneak in, and you can't really do anything about it. It's not a perfect world. So in addition, we can use title grammar to do feature engineering for the CRF. Namely, it turns out that some of the more effective features for the CRF model is something like word at position J is in dictionary X and not in dictionary Y. What that means is when you look at a query and the model is trying to featureize around a particular location, it will say, well, what is this word? Oh, it's some word like director. Oh, actually, it turns out to be in the dictionary of known titles, and it's not in a dictionary of skills. Good, so I'm going to fire, and eventually I'll see something like this in the test set. I'll have some weight, hopefully not indistinguishable from zero associated with it, so it's a good feature. Unfortunately, if you have features like this and your dictionaries are all noisy and you have skills and titles all mixed up together with companies and locations, then you're pretty much hosed, because then you will learn nothing. This feature that would have been really awesome is actually going to turn out to be of no consequence at all. So the title grammar that was developed was also used to clean title dictionaries, which initially were really noisy, by removing a bunch of noise from it, as well as skills dictionaries to augment them and to remove titles from skills and skills from titles, thus improving the quality of the features. And finally, you can use this grammar to post-process your results. So CRF is a probabilistic model, which is beautiful and very robust and has fantastic generalization, and we love it. But sometimes it makes really obvious errors that you shouldn't be making because you know they're wrong. And something like sales engineer, which is a two-word query, if it's tagged skill instead of title, is embarrassing. You shouldn't do that. You should fix it, and you should fix it and you can fix it because you know that you have a title grammar that can correct something like sales engineer to a title if it is labeled as any other entity, because it knows that engineer is a core occupation and there is a pattern that fixes it beautifully to what it's supposed to be. And actually, post-processing turns out to give about 2% improvement on the overall F1 measure. Speaking of that, the results on frequent short queries, so these are short queries less than 4 words long with the original training data for skill and title, skill being our main object of concern because it's only 63% F1 measure, was able to go up by 13% with the added training data due to the title grammar and added features, again, that was reliant on the grammar and the post-processing. So it gave 13% improvement. Smaller improvement in title, but for reasons that we kind of were okay with it how it was, and we didn't really fine-tune a lot of features towards improving the title at the time. The more difficult thing to do was to improve rare and long queries, for which we didn't build special training sets because that requires a lot of segmentation. This is actually a much harder problem. So anytime we have a query longer than 4 words, it could be a bunch of things squeezed together there. And with the original training data and no post-processing, it was at 65 because most of our original training data was actually from long queries. But with added training data and added features, it went up by 3%. And with added training data from the long tail, that went up to 70. So it was actually an improvement, but a much harder thing to do because we didn't have just the right kind of data to be able to add to it. But still more than more than the initial. So in sum, title grammar solves the shortage of consistent training data by labeling new titles consistently and correctly and adding them to the training set, assisting in inference and labeling of skills and queries. And it also allows us to engineer better features and correct certain types of obvious errors that the CRF makes using post-processing, thus giving us about 13% improvement on skills in frequent queries and 5% in rare queries that are longer and harder to get. The method that I was talking about today can be tailored to any kind of short text, really, like search queries for product names, like on Amazon or eBay or what have you, or occupation names in various domains related to occupations, or really any entities with stable linguistic patterns. Thank you. Is there any other questions?
I'm sure people have questions.
Yeah.
So when you were showing the numbers, for the skill tagging, I noticed that when you added the training data and stuff like that, it seemed like precision went down.
On this,
Yeah.
on the long tail.
On the long tail.
Because we added short data.
Yep.
Because again, the data was consistent, but it wasn't what we were testing. We were testing longer queries. So if you add data, even if it's good, but it's not the right data, it's going to go down. If you add the right data from the long tail, it'll go up again. That's.
So any ideas on how you might tackle long tail data?
Unfortunately, because there is so much segmentation ambiguity, you have to maybe, like, if you have you know for sure that the first 3 words are a title, then you can look for something longer. Without human labels, it's really hard. It's really hard, yeah.
So did you use the query logs for getting the behaviors?
We use the query logs to get the data that we labeled ultimately, but we use the titles to build the grammar. We absolutely use the query logs, and as the main thing from which we were learning. Yeah.
Okay, so which part did you use for the query logs? So I understand basically the title data is the one that basically you build everything upon, but where did you use the query logs?
The query logs were used when to obtain the actual training data. We used the grammar to label. So whenever I say something like, sorry. Raw queries. So these are raw queries from the query logs, like art instructor, and we're going to label them using our knowledge of what that word art and instructor might be.
Okay, so it's kind of like you were testing the thing on your query logs.
Yeah.
Just to find out basically
Yes.
how
Yeah.
And then did you use for the query logs the clicks on specific profiles?
No, we only used the fact that they were frequent queries, the fact that they were really frequent.
So nothing
Yeah.
related to it.
Not in this particular experiment, no.
Do you have a sense of how much adding more training data contributed to your improvement versus the features?
I actually had, so it was the bulk. The bulk was the training data. The features were like about 5% or so, maybe 4%, but it's not, they were interrelated because features you were able to add the features because of the grammar, but you couldn't, if you remove that training data, especially for short queries of which we didn't have enough to begin with, the results are pretty dismal, yeah. I think there's next talk, so happy to talk later. Thank you. Thank you so much. It's great. Thank you.